My name is Satish Katpally. I'm part of the VMware's cloud provider business unit, and we offer the VMware stack through cloud providers to enterprise customers. Just as a show of hands, how many of your enterprise customers versus cloud providers? Enterprise? Cloud providers? Awesome. Great. Thanks for being here. And the idea is to connect both of you guys together so that how you can consume the SD-WAN services through cloud providers. There are other sessions that go into more detail on the technical content, and I'll try to cover as much as possible. But the idea here is to convey that you can consume SD-WAN services through your preferred cloud provider, and you have one, I can guarantee you, in wherever you are in your region. We cover about 4,500 different cloud providers, so you should have access to at least one, if not a couple in your regional area. With that, let me just get started. So the idea here is to go through the standard VMware disclaimer, just give it a couple of minutes to take a look at it. We need to do it it's a requirement. Okay, so here's the agenda I've planned for today. So I'm going to start with covering a few cloud service trends, and I'll check back with you, enterprise customers, to see exactly how you're consuming these services, and then sort of talk about why SD-WAN is going to matter as you consume these services. Why should you care? Why should you care about not just SD-WAN, but also why should you care about consuming it from a cloud provider versus running it yourself? Those are the two key takeaways, if anything, that I want to convey to you. And then going to the details of NSX SD-WAN by VeloCloud, that's the key technology piece, and what are the components, how does it work, and how you as an enterprise and how you as a cloud provider both can deploy this together or consume the services, and how that makes your overall multi-cloud cloud migration and everything else a lot better. How does that sound for an agenda? Or does anybody else want to cover anything else? I'm happy to be flexible and change the content because depending on the audience, Any other comments before I move ahead? Awesome, great. So let's start with cloud services trends. Most of the cloud budgets, from what I can gather with IDC and everybody else, is moving beyond infrastructure, which you might already experienced. So it's the rest of it equally split from SaaS hosted to managed services to security to professional services. So this is where cloud providers, please pay attention, because once you move away from IaaS, that's where most of the cloud spend is going in the next few years. So you might want to focus on how do you offer these types of services going forward. And enterprise customers have told us these are the top managed services that they're looking for or they're already deploying. So backup and recovery, disaster recovery, support, mobile services, archiving. How many of you are consuming at least the top two already now through cloud providers? How many of you are deploying it by yourself? Okay, great. Top professional services, how many of you are starting with cloud migration services? How many of you have already done it, either by yourself or through your cloud provider? Cloud providers, how many customers have come to you asking for cloud migration services? All of them. Okay, great. So this is going to help you, migrate them faster. That's the whole point of this session, was to help you do this. So why should you care? Why does WAN affect cloud migration? Right. This is your typical customer scenario. Their data center, their branches, connected through various WAN protocols, MPLS, LTE, broadband, and then either a breakout to their SaaS services or coming to you as a cloud provider in your data center. So how many of you can relate to this? Enterprise customers. Great. So what does this do to your, when you move applications over to cloud provider data centers? You're going to have to address complex WAN issues, multiple carriers, then application performance, because once you move your, for example, VDI as a great use case, or UCaaS, that some of the cloud providers have already solved, but that affects application performance. And as you move from a hosted cloud provider cloud into a hyperscaler, for example, VMC and AWS. How many of you are deploying VMC and AWS? Yeah. So as you move from your hosted to VMC, imagine the WAN complexity of having to make sure the peering works, the routing protocols are set up, and your application performance is all, all good compared with the multi-cloud. So this is where SD-WAN comes in. I'm going to give you a brief intro on SD-WAN. There are a few other sessions that go into a lot more detail. I'm just going to cover it very quickly and then get to why you should care about why cloud migration stuff happens. So WAN's getting complex. Most of you already know this from control, visibility, cost, security, and then long cycle times. This is a typical, if you enterprise multiple branch sites, you're deploying it yourself. This is the typical topology. And then most of you are doing backhaul to your data center before you go out to the internet breakout. You're probably not doing it direct from the branch to internet, mostly for security issues. And that affects your WAN traffic, obviously, because you got to backhaul every branch traffic all the way into your data center before you get out to the internet, even for recreational traffic in your branches. So how do you deal with it? And then if you add your SaaS, and then if you add IaaS and PaaS that you're consuming enterprise customers, this is what it becomes in terms of complexity for WAN. So lack of visibility, security challenges, not just on your branches, but also on your cloud breakouts and on your hosted cloud environments. And cloud providers have to solve this. And if you're doing self-service on hosted clouds, enterprises, you'll have to solve this too. So how do you get around this? From hybrid cloud complexity to unpredictable performance, I've had plenty of customers come back and tell me the biggest complaint I have with my WAN network is my branch users putting in service tickets every 2 days because the application performance sucks. So it's not about technology, it's about application performance to have your end users be consuming applications wherever they're deployed. Right? That's the whole point of multi-cloud, is being able to map an application to the cloud where it makes more sense from economic perspective, from a performance issue, and from all the application level services that you're consuming. So given that, let me just do a very quick example of a retail store. Right? Here's what happens typically with a store with point of sale, running signage, guest internet, mobile checkout, virtual desktops, mobile kiosks, and trying to get to both the corp data center and to their SaaS applications. This is a typical case where the bottleneck is right, across the wide area network. So bandwidth is an issue, security is an issue, visibility is an issue. Right? So this is where SD-WAN sort of comes in, and these are the typical challenges I'll lay out. If you have WAN complexity, your application performance is affected, and you don't ramp up fast enough on multi-cloud, your cloud costs are going to be high, your users are going to have lower satisfaction, and the more complex it is, the slower your multi-cloud adoption. What do I mean by multi-cloud adoption? Well, first, going to a cloud provider to consume their hosted services, and then from there to a hyperscaler. For whatever reason, most enterprises deploy at least 4 clouds. That's been the average across enterprises across the world, at least 4 clouds. One being a cloud provider cloud, one's a hyperscaler. For whatever reason, you're going there to either as just a pure backup storage or consume advanced application level services like AI and ML in the future, or as simply as just because it's cost prohibitive, right? So that's the reason to. So the idea is that if you can solve WAN complexity, application performance issues, and then the multi-cloud on-ramp, your customers are going to be a lot happier. Enterprise, your users are going to be a lot happier, and for cloud providers, your customers are going to be happier. And the reason to do that is through SD-WAN. So how does SD-WAN do this? Just a quick introduction. In the customer use case that I showed you, a typical branch edge, you connect to your data center, and then you go to your SaaS applications. So either there's an overlay. That SD-WAN is an overlay technology. You connect your branches to your own data centers, enterprises, or to your cloud provider's data center. And then the internet breakout can be right from where the branch is, going to the SaaS applications. You don't have to trombone the traffic all the way into to either your data center or to the cloud provider's data center to do that. So that's the overlay. And many companies do it differently. We do an overlay at the layer 2. Most of the companies do probably layer 3, layer 4 overlays. And there's different ways in which they map applications to WAN paths. I'll go into that in detail. But the idea is to solve these three things: simplify the WAN management, assure the application performance, and then manage your on-cloud, multi-cloud on-ramp. Either you do it yourself, enterprises, or you have your cloud provider do it for you. In this session, what I want to convince you, enterprises, that it's easier for you to consume it from a cloud provider. Don't even bother investing into SD-WAN on your side. There are plenty of cloud providers available that can bundle this in addition to all the other services you're already consuming. Those are the top 5 services that I showed you, from disaster recovery to all the other services that they already they are on offer to you that you already consume, and this could be another service. And this is why enterprises should consider what are the benefits. Just let me quickly go through these. Oops. So reducing your service costs. The benefit is lower WAN costs, like I went through multiple times. Imagine enterprises having 10 to about 500 to almost, in some cases, 1,000 different branch sites, connecting all the way into your data center. And some of those branch sites might be going into your cloud provider data centers, depending on what applications you're running where. And some of those branches might be going straight to hyperscalers. You're probably investing in direct connect or express route right now, probably to get to your hyperscaler deployment. How many of you are deploying at least a dev test or some mission critical app in either AWS or Azure by yourself? Okay. How many would like to? Okay. Which one? AWS or Azure? Which pick AWS? Okay. And do you do it through direct route now, or how do you do it? Nothing yet. Okay. So before you even get started on that journey, what I'm trying to convey in this session is the multiple choices. You could either go to your telco and get another link, a direct connect or another MPLS link to get to your hyperscaler, or you could do it through SD-WAN. And the cloud provider can do that for you. You don't have to do that yourself. That's the key message from this session. If you walk out and somebody asks you, what did you learn in this session? Just tell them one thing: cloud providers can do SD-WAN for me. I don't need to worry about it. That's the one takeaway. And what type of services can you consume from cloud providers with this SD-WAN? So managed WAN. A majority of cloud providers now are actually managing customers' MPLS links for them. Managing it through the telco, but managing it for them. How many of enterprise customers, how many of you are having your cloud provider or somebody else manage your telco MPLS link for you? Yeah. And so those managed services, sort of, single point of billing and all the other issues that come with it, telco management, truck rolls, delay of service, all that, everybody's familiar with this, especially you are, I'm sure. So that's one thing that you could sort of move it to the cloud provider. The next thing, application SaaS and performance services. The key thing that you as enterprises care about is how well is my app performing? How well is my business running based on that app performance? How many of my customers are connecting through this app? What's the load? What's my cloud cost? Right? So those are the things that you worry about from application and SaaS performance issues. And then simplified cloud access, because you want to get to your cloud. As you migrate to the cloud, you have plenty of choices. Cloud provider hosted cloud, that's probably the simplest, the first thing you probably do. And then from there you get to a hyperscaler or your SaaS clouds. So given at least 4 clouds, how do you simplify your cloud access? And how do you know that the app you're running in a cloud is the right place to run that app? How do you monitor that? Right? And then as you have multiple managed edges and branches, the idea there is that you don't have to manage them with a truck roll, with a physical presence, and have IT expertise in every remote branch. And that's been increasingly becoming an issue, especially with IoT and those type of technologies, where the staff on the IoT side, your operational technology side, is not necessarily IT, conversant in IT. So you might want to simplify that branch as much as possible. And by branch, we just don't mean an IT office, your branch office with a dedicated IT center. Branch can be as simple as your fleet running across the country to a remote, like a telco. Telco's fleet would be a remote telco tower being automatically being managed without any staff there, too, right? So we're expanding the definition of the branch, not just a IT branch or a branch with people running your business. So all this is possible through cloud providers, and again, I'll go through exactly how SD-WAN will get it to you. And so for cloud providers, specifically, these are the things you can expect. You can offer app monitoring services. Most of you probably do app monitoring when you run it in your own data center through vCenter or other technologies where you have to be able to know exactly how your app is performing. Now, when you move it into hosted clouds, this is what you can do. Right? And then app and firewall and web security, cloud VPN, that's another big issue. Most customers' branch office is usually an IPsec or L2 VPN into your own data center. Now, imagine having to do multiple branches with multiple L2 VPN tunnels as your number of branches explodes, and then having to go to not just your data center, your cloud provider data center, and to your hyperscaler. How many tunnels does that make from every branch? How do you manage that? How do you manage the key exchange, the IPsec, depending on what type of flavor you deploy with L2 VPN? So given all that, PCI compliance becomes an issue too going forward. Like, how do you make sure that your PCI traffic is not getting mixed up with your recreational traffic, your guest login traffic, and how do you separate it out? So how do you get to PCI compliance? And then on the multi-cloud on-ramp, as enterprise customers ramp up, these are the benefits for cloud providers, and these are also the benefits for enterprise customers, right? So enough of benefits and what the over structure is. Let me get to actually the meat of it so that you can actually tell me if this works for you or not, and then we can have a Q&A in the end. I'll set aside about 10 minutes to go into more detail, okay? So you must have heard of the virtual cloud network, and the reason I'm starting here is because of NSX has been expanded into virtual cloud network as more of a portfolio, not just NSX data center, NSX cloud as part products within the portfolio, but the Uber messenger on NSX is that it's a virtual cloud network. And why do we call it a virtual cloud network? Because the idea is to expand it not just into data centers where you've mostly known NSX to operate in data centers, but as you go beyond that to the branches, this is where SD-WAN part comes in. And then our NFV solutions get you into the telco NFV type of environment where you could also deploy NSX NFV in your branches as well, obviating the need for hardware solutions. And then as you get to edge and IoT in the future with hyperscalers involved wherever you run them, that's another piece where NSX is expanding into as well. So that's the virtual cloud network. The idea and the message around this is that we connect and protect across any workload, any environment. So you can see apps around the perimeter, and then you have from containers, public clouds, telcos, wherever the app is running in whatever flavor, the connectivity, the automation piece are all sort of built by the NSX portfolio. Regardless of the hardware underneath, that's the idea. And so the messages around these are, it's programmable and very application-centric. NSX, most of you are, how many of you are network buyers? Great. How many of you are focused on purely on apps? And how about, are there cloud engineers here yet? Okay, great. And so the combination of all of you, it brings it to the programmable and application-centric nature, right? DevOps is becoming, and cloud engineering is becoming more and more relevant. How do you deploy an application on a particular cloud? Well, who's going to answer that question? Somebody who needs the NSX piece, somebody who needs the underlying hardware, WAN protocols, and everything else sort of coming together. Hence the message around programmable, application-centric, and automation so that it becomes agile and flexible, right? And so this is the portfolio that gets you there. And we're going to dive into the SD-WAN, VeloCloud, and sort of go into the cloud provider cases. And so starting with data center, which you're familiar with, NSX cloud that connects across multiple clouds. When you go from your data center to your hyperscaler, you can have NSX cloud directly connecting the two of them. And SD-WAN running underneath as the underlay technology. So with that, a nod to our cloud providers, because this is where you enterprises can consume all these services. VCN plus VCPP makes for a powerful combination. All the managed services that you're either deploying yourself or cloud providers who are offering them to you can do this through the cloud provider platform. And if you've seen our announcements this year with cloud provider platform around, how many of you are familiar with VCPP? Okay. You must all use VCD, vCloud Director. So all the new announcements around vCloud Director and all the new Cloud Pod and the new Cloud Hub, all of those pieces that we are building to help you run managed services and to help enterprises consume those managed services run on top of the cloud provider platform, which has NSX underneath it. And so the previous slide where I showed you this entire portfolio is available to you through your cloud providers as well. So that's the essence of VCPP. And so here's the introduction into what is NSX SD-WAN by VeloCloud. 3 different components. Typical scenario, branch to the data center, and then SD-WAN has 3 different components. Let me just get you into the solution components. So the WAN edge is number 1. This is where the customer site you deploy this WAN edge. It's either a hardware box or you could do a virtual form factor as well. Depending on what you have for a branch connectivity now, if you have a Cisco ISR or a Juniper router or any other edge connectivity device, this works with that too. So this could be the front end on top of your existing branch networks. And most cloud providers, as you deploy and connect more customers onto you, this is what you send over to your customer site to deploy and say, hey, here's how you connect to me. And you manage it through the cloud. There's no physical management at all. And then once you deploy that, there's the orchestrator and controllers that help you manage through the cloud. That's the other piece of the management. And then the gateways. These are the critical pieces where the edge connects into the gateways. I'll show you the exact. Here's the typical topology. Those 3 components work this way. So if you start from the left side on a branch, you deploy the edge by VeloCloud. That's either the virtual form factor or the hardware appliance. The hardware appliance can do multiple WAN links. You can do, have SPF to do fiber. You could have SPF to do gigabit Ethernet, Metro Ethernet. You could have USB with a 4G connectivity on it. And you could have 2 or 3 different ports on it to do multiple SPFs. So you could do anything from 50 megabits per second per site all the way up to 1 gig per second on a single device. So you scale the bandwidth as you need to. So you can cap the bandwidth, and then you can obviously scale the bandwidth, all cloud managed so that you can do this on demand. No truck rolls, probably, that should be music to cloud providers' ears at least, if not the telcos. And enterprises, you don't have to worry about it. That's the key message. And so once you deploy the VeloCloud Edge, it sort of connects you to the gateways running in the VeloCloud gateway. This is the layer 2 connection that forms the layer 2 tunnel. This is the proprietary protocol VCMP that we run from the edge appliance all the way into our gateway. And the gateway, the beauty of the gateway is that they are spread across the entire globe. They could be running in AWS, they could be running in the provider cloud, they could be running in enterprises, your own cloud if you want to. And the idea is if you're going to a cloud provider directly, I'll show you the use case, the gateway can be in a colo like Equinix. And so you can have and the idea is that instead of having a IPsec or L2 VPN tunnel from every branch into your colo or into Equinix, you connect them all into the SD-WAN gateway, and the SD-WAN gateway to your colo, to your Office 365 or whatever service you're consuming, that's a single IPsec tunnel. So you can imagine the, the reduced complexity in terms of number of tunnels, and also the overhead that gets reduced in terms of throughput. You're just sending all of your traffic across multiple links into one gateway, and the gateway, and this is your dedicated gateway, by the way. Nobody else is using it. And it extends your IP addressing all the way into your wherever cloud you're connecting it to. So you don't have to worry about, do I need to do extra NAT and do everything else to get to your application, whatever cloud it's running in. So given this is the typical, so like I'm showing in the bottom, you see this is the SD-WAN by VeloCloud if you're running an edge on the data center as well. because that's the two edge devices talking to each other through the gateway. This way, you can reduce your WAN costs on your data center side as well. And if you have a legacy data center that you don't want to deploy the edge appliance, the gateway can connect to your existing branch router through a BGP IPsec tunnel anyway. So that works as well. So it's a greenfield, brownfield, both are possible. Now, just giving you a brief overview, this is what an orchestrator looks like. So there are no CLIs. How many of you are fed up of CLIs? Whatever CLI flavor, I'm not particularly. I wrote Juniper CLI, I deployed Cisco CLI, so I'm agnostic, but they both suck, right? So what this is doing is, this is purely a web-based interface, straight running, the edge appliance and the gateways are all running REST APIs and JSON APIs all the way up to into the orchestrator. So there are no CLIs. All you do is, through the web interface, to the orchestrator interface, you get your own portal as an enterprise or as a cloud provider. There are 3 different layers. So if you're a cloud provider, you get your own provider layer deployment, and then you could manage multiple tenants underneath it, each of which can be an enterprise customer. Or if you're an enterprise customer, you could have, the top level be VeloCloud operated. You could have your own access into the portal, and all of your branches or different organizations underneath it could be. So you get 3 levels of orchestration is the point. And the global gateways, you see them spread across the entire globe. So you have plenty of choice wherever your regional, your branches are, or wherever your cloud provider is, or wherever your hyperscaler is. So all you do is connect from your branch into one of these gateways, and it picks the gateway that's closest to where your application's running. That's the other piece of the puzzle is which gateway does this particular branch running in, for example, Kansas City, where should I connect it to? You don't have to worry about it. The gateway, the orchestrator that's running figures out exactly what gateway is the closest to what your branch, wherever your end destination is, whether it's your own data center or whether it's a cloud provider data center. Okay, I'm sure there are plenty of questions. I'll answer them after. So given that, let me show you what the secret sauce is. This is the differentiator for us. Most SD-WAN providers map an application onto a WAN link. Like imagine a typical branch site with, you have a telco WAN link and you have a broadband Ethernet link, just to simplify things, two separate links. And the MPLS link is SLA guaranteed. You get to your telco, the telco runs an MPLS or some other backbone, and then gets you into your data center and to your edge router, right? Most SD-WAN solutions are on a per packet basis. They map an application on a branch into a WAN link. But what we do is called DMPO, Dynamic Multipath Optimization. We route packets based on a per packet basis, not on an application basis. So if you have VDI traffic, and let's say you have a guest login running Facebook traffic, right? So we take your VDI traffic, and you have a way to map it to say, VDI traffic should get 30% of the WAN bandwidth that I have. And Facebook can get whatever, the guest internet traffic can be limited to whatever tier you want to limit it to. And what we do on this end is, given that you have MPLS link and the broadband Ethernet link from, let's say, Comcast, we monitor the link between the edge appliance and the gateway, just to make sure what the jitter is on a millisecond basis, on a per 10 millisecond basis, so that we can reroute packets and put the packet onto the right WAN link whenever there's a jitter or tolerance. For example, in this case, if the broadband Ethernet cable link is showing you more than 2% packet loss, which you can set this in the orchestrator too, then you can switch over the traffic onto the MPLS link. And once the Comcast cable link gets, the jitter goes away, we can map it back. So you can imagine from a topology perspective what this does, right? Most companies do it on a per application basis because they don't do packet reordering at the other end. We establish a layer 2 tunnel and we move packets on each link on a per packet basis. That's the key differentiator for VeloCloud. And this guarantees VDI application performance. This guarantees your UCaaS and any of the video intensive applications as well. And imagine the bandwidth multiplier too. Now you're not using it as a standby active mode. that you're failing over to your broadband when your MPLS goes away, you're using them both at the same time. Right? So that's the other two key benefits is one, your application performance is never, you can set the threshold, it never suffers. And two, you're now multiplying your WAN capacity. If you need to do workload migration and move a massive VM over, imagine doing that across an MPLS link and what the cost would be and what the throughput would be versus being able to move the same VM across two of these links both at the same time. Right? So that's the value. And then here's another example of SaaS and data performance. This is what I was alluding to earlier, and I'll show you examples of these two with real-world examples of how some customers have deployed these. So typical 50 megabit box file transfer with VeloCloud and without VeloCloud, that's the difference. This is the multiplier effect you get from spraying packets across each on a per packet basis across multiple links and not having to worry about layer 3 packet reordering issues. So that's the multiplier effect. And in addition to that, we also allow distributed service insertion. So most of you, okay, great, you give me, I can move my applications, you give me extra bandwidth, what about security? Right, that's the number one key when you worry about moving your applications from the branch to different parts of your data center or different clouds. So we work with all these partners, starting with Palo Alto, Fortinet, ForcePoint, and you could insert those security, whatever you want, from the IPS, next generation firewalls. You could do that in the data center, which you're probably mostly doing that now, but you're having to trombone traffic all the way into the data center. Imagine being able to deploy that right on the edge appliance with VeloCloud. So we allow VNFs to be deployed on top of the VeloCloud appliance. So you can have a Palo Alto networks running right on the edge appliance, giving you branch security, same degree of security, and similar consistent security is the other way to say it. If you as a cloud provider are offering security as a service, for example, and you are having to have all of your enterprise customer traffic come into your data center before it goes out, you apply security right there. Imagine being able to move all of that security right into the customer's branch. Consistent, the same Palo Alto Networks firewall running right on the edge appliance. Right? And so if the traffic's leaving from the branch going straight to the internet breakout or coming into your data center, it's going through the same firewall. Right? And you could do that at the gateway level as well. If you run your own gateway, for cloud providers, this is very relevant. You could consolidate a whole bunch of enterprise customer L2 traffic coming in, a bunch of different branch sites, have them all connect to their gateways, and have them all go through the exact same either Palo Alto firewall or any other firewall that you would deploy in your own data center. So imagine being able to do that wherever the application is, wherever you're locating the gateways. Right? That's the flexibility. Now, let me show you a couple of use cases. So this is a typical enterprise deployment. Right? I know I'm running a little bit fast, so let me just slow down. And I know everybody had lunch, so before you nod off and I put you to sleep, let's wake up a bit. And I'm going to ask you a couple of questions now. Just how many of you are deploying this type of scenario by yourself, enterprise customers? Let me start with them. A typical branch, your own data center, a new data center potentially, and maybe you're going to a hosted cloud. Yeah? And yeah, cloud providers, how many of you are offering this type of service to your customers, having them come into your cloud providers, right? And so obviously bandwidth is an issue, depending on where they're located and stuff. And so step one, enterprises, you can go to the cloud providers and just ask them, hey, I am using a private MPLS link right now to come into your network. It's expensive. I'm going to add another broadband Ethernet connection potentially, get another Comcast line or whatever temporarily, especially when I'm migrating workloads because you need the extra bandwidth just for bursting capability. I don't want to manage that. Cloud providers, while I'm moving my workloads to you, can you take care of that for me too, right? That's the piece here. So cloud providers what you can do, enterprises, when you ask your cloud providers, all they need to do with NSX SD-WAN is ship you the edge appliance or download the VNF onto your edge appliance, whatever you're running, either It works with your existing, layer 2, layer 3 switches. And then they're going to deploy a gateway either in the VMware's cloud or in their own cloud, depending on what the operational model that they sign up to. And voila, you have connectivity into them directly through your existing MPLS and public internet links. And next day, you might decide, I'm going to remove the MPLS link. Nothing changes for you, right? You have your existing broadband Ethernet connectivity. You might add a secondary line with broadband Ethernet just for the workload migration case, and that solves that. So this is a managed SD-WAN service is the definition of what I had presented earlier about what cloud providers can offer you. So, and there could be multiple of your branch sites, right? So they would ship it to, they would deploy this to multiple of your branch sites. There's no IT expertise necessary from the customer end. Cloud providers, ship it to the end customer. All the end customer has to do at the branch location is just plug it in. Once they plug it in, the edge appliance connects to the gateway through the orchestrator, gets its config pulled down because that's the service you subscribe to, either a 10 megabit service or all the way up to 1 gigabit service in increments of 10 to 50 to 100 to 1 gigabit per second. So all that config is pulled down, and then it gets automatically deployed. The tunnels are already set up, and traffic just starts flowing. So two things. One, the IT expertise needed at the branch is zero. All they have to do is plug in. Anybody should be able to do that, power cord. And you as a cloud provider or enterprise customer, you're going through the cloud and managing it. So you're not doing a truck roll, you're not reconfiguring the device, the bandwidth is pre-provisioned, the amount of bandwidth that the particular customer, that branch has signed up for. Imagine, I'm sure not all branches are equal, right? So some branches need more bandwidth, some branches need less. You could configure the per branch, per site bandwidth requirements in increments of 10 megabits per second. And that, you could change that within 2 seconds if you need to, if you need extra bandwidth for that particular branch for the next, and the billing is monthly. So you don't have to worry about if I switch over to a higher tier, how far am I locked into? The billing is monthly. So that's the easier piece for both enterprise side and customer side, right? So that's the typical deployment. And what's the number one worry for you enterprises as in this model? What would you say is your number one worry? Sorry? Exactly, thank you, yeah. You probably saw the next slide, didn't you? No? Okay. No, that's exactly my point, is it's a cloud provider management that becomes an issue with multiple telcos. You're gonna have to go to Comcast to manage one link, you gotta go to a telco to manage one link, right? And as you add, I'll show you in the next use case, as you add direct connect or express route to get to your hyperscaler, the number of links explodes. So it's either you manage that or have the cloud provider manage it for you in addition to all the other services you're consuming from them anyway. Right? So let me pause there for a couple of minutes and just let's do a quick poll. Based on what you've heard today with SD-WAN, how many of your interested enterprise customers only would consider cloud providers to manage the SD-WAN or deploy it yourselves? Let's start with how many of you would choose the cloud provider side? Okay. How many of you would deploy it yourself? Either way, okay. There's pros and cons on both ends, but the idea is there's enough flexibility for you to do either. Given the number of branches, whatever you're trying to do with, depending on your cloud strategy, the pace at which you're adopting clouds, how you go to your cloud provider to do this for all the other services that I showed you before, or starting with the basic exploration of, hey, I'm going to migrate to, I want to move a few VMs or applications into a cloud provider cloud. You could find a regional provider. How do I do that? What's the implication on WAN for me? And when I do that, what should I be worried about, right? So those are some of the things that enterprise customers, I want you to think about when you start going down the path of cloud migration, either with small applications or dev test. Since from the earlier poll, nobody's deploying on AWS or Azure anyway, so that's not an issue yet. But large enterprises, from some of you, as you get to that point where you start to deploy, let me show you an example actually before I speak too fast. So here's the other typical case. Most customer data centers and branch centers, if they're going to AWS and trying to consume a service, let's say you move your dev test environment, or the next website that you're building in beta is going to be deployed on AWS. To make sure that you have a connectivity to wherever you're running your latest refactored application, whether it be the new database services you're consuming, or you're deploying next generation analytics to capture more of your customer segmentation. All those, those are just some use cases I'm throwing out. But the connectivity, when you boil it down, you have the typical internet connectivity, IPsec, which I'm assuming, or L2 VPN into either your own data center through MPLS or to your cloud provider data center, the simplest use case. Then when you move to a hyperscaler, like let's say AWS, you probably start with a direct connect, because that's the immediate offering from AWS that encourages you to go to a telco and say, hey, get me a direct connect. I go straight from either my data center or my branch straight into where my AWS application is running. So for a bunch of different reasons, you might want to do that. But the argument there, again, is that it becomes a complex multi-link WAN management, multiple direct connects, multiple your own MPLS links, and the broadband Ethernet link. Now you got to manage 3 different links. Well, that also increased WAN costs, because in this case, all your direct connect traffic cannot go on the other links. Right? Otherwise, it would be tromboning all the way into your data center, going back to AWS, which defeats the purpose. You want to get straight to your AWS deployment. So that's the application WAN cost in terms of performance. And then as you keep doing this, imagine most enterprises have told us 4 different clouds, right? You have one for AWS and one for Azure too. So imagine 2 different direct connects, one express route, one direct connect into different scales. And all you're consuming that direct connect is with that dev test environment or whatever you're running in AWS. So that bandwidth is underutilized, let me put it that way, mildly. So how can you improve your WAN utilization, right? So this is what SD-WAN can do for you with NSX SD-WAN, is you run the edge appliances everywhere in your data center to your branches. That connects to the WAN VeloCloud gateways, and you could deploy the gateway, the VeloCloud gateway, right in your AWS instance. So imagine being able to, this was the use case I was mentioning earlier too, like the L2 tunnel between the edge and going into the virtual SD-WAN edge on the other side with AWS is right where your application is deployed. You could substitute AWS for your cloud provider, and this would work the same way. Right? The idea is that there's one hop from the virtual edge into your AWS work instance, and the number of tunnels gets reduced, the amount of bandwidth gets tripled in this case, depending on how many WAN links you're deploying. So that's the idea in avoiding the expense of direct connect and being able to improve your application performance. So as you think of migrating some of your workloads into AWS or Azure or hosted cloud, this is another use case that you need to consider. And the next one, how many of you have torn your hair out with IPsec connectivity management between branches and your data centers? Yeah, so I can't claim that I lost my hair because of that, but let me start with IPsec is a complex problem to solve, and just the sheer number of tunnels. It's almost a full mesh that you need to connect to get from every branch into either your direct data center or your backup data center or your cloud provider, right? That's at least the 3 tuple that you need to consider. Once you do that, the number of tunnels from each branch into each of those data centers just explodes. And if you need branch-to-branch connectivity, all that traffic has to go all the way up into the data center and then back down again. Right? So that's an inefficient use of your WAN links. So what we do with VeloCloud, again, the same reasons apply. Complex IPsec tunnel management, increased WAN costs, and then you got poor application performance. So the solution, what we do with NSX SD-WAN is there's a L2 tunnel, like I said before, from each of those branches into the gateway, right? And all of the IPsec is automatically managed between them because all that is a layer 2 encrypted tunnel with our own proprietary layer 2 encryption protocol called VCMP. So we don't incur the overhead of IP, GRE, and all the other tunneling protocols to get from your branch into the gateway. It's a pure L2 connection. And then from the branch to the gateway, there are just 2 tunnels, one into your main data center, one into your backup data center, and then if you have a cloud provider, that's the 3rd tunnel. So you took, let's say you had 10 branches, a 10 by 10, which is almost on the order of 100 different IPsec tunnels, boiled it down to 2. Right? That's the simplicity that you get. Either you could do it yourself, or imagine the cloud provider doing this for you. They run the gateway in their cloud. All of your branches connect to them. It simplifies the IPsec management on their end as well. Right? And then the second case that I mentioned, what if you need branch-to-branch connectivity? So when the edge gateways are connected into the first time they connect into the edge gateway, the edge appliances, they establish the layer 2 tunnel. And as they figure out adjacent edges that are around, because it's either they're discovered through what we do with EBGP and advertised routes that are the underlay routes. Once we do that, you can have the branch-to-branch edge appliances establish a tunnel between themselves too. So now your branch-to-branch traffic is going through the internet and not having to go all the way into the gateway or into your data center. So the traffic is now, your WAN utilization goes up, your data center and WAN costs are reduced because you're consuming more and more of your broadband Ethernet connectivity between the branches. Right? So that's the other advantage that's why I highlight sort of these 2 cases to show why it's important, or why this NSX SD-WAN by VeloCloud works. Now, most of you are probably thinking, okay, how do I deploy this on my branches now? So given these are the different options you have in terms of being able to deploy, you can coexist with L2. If you have a layer 2 switch with CE either run by the telco or by yourself, or cloud providers, imagine this is your data center end, this is what you're looking at. You could run VRRP between the VeloCloud device and your existing CE device to have virtual router redundancy, and you could have it in an active standby mode so that it can fail over from your existing layer 2 device into the VeloCloud device running on the internet or on the MPLS. You could have it coexist as an L3 router as well, like running BGP between the 2 as a peer, right? So you have the same default router from your layer 3 switch, and you could have an active standby mode. So this gives you HA right off the top with the additional advantage of the multi-DMPO giving you WAN complexity, right? And then ultimately, our goal is you replace everything else with the VeloCloud device. This is your CPE device. You can manage it through the cloud. Cloud providers, you can do this. You don't have to go through the telcos. You could just, whatever the WAN flavor of WAN that you're deploying, wherever it is, 4G all the way down to a Metro Ethernet, you could deploy this as a CPE replacement technology as well. So how many of you are in the first 2 enterprise customers? Either you're running an L2 switch or an L3 as your current edge right now. Any network buyers in the audience, or everybody's mostly either cloud or application or IT? Yeah. Okay. All right. So how can I address any of your other questions? Let me see. So here are a couple of customer use cases, right? I showed you a retail example before. This is a real-world example with Brooks Brothers, and their challenge was network outages. That meant lost sales and multiple different sites spread across the country. So how do they address it? Continuous uptime, and then the removal of the backhaul of traffic. That was the key advantage for them, so that every Brooks Brothers store didn't have to come back all the way into the data center before it went out to the internet. And next time you walk into one of these stores, you're going to have your own internet connectivity from the store itself. Then you should wonder how that traffic is getting to wherever you're going on your apps, right? So that's the internet breakout that they've deployed, that they go straight from the edge appliance to the cloud gateway directly to your SaaS application. Doesn't have to trombone all the way back to the data center. And so that's the sort of remote, not remote, but large number of sites, probably needs high degree of connectivity, but not much traffic. Point of sale traffic is sporadic, but it's not much traffic. And at the end of the day, they do a backup of the entire branch, but during the day, it's not that much in terms of bandwidth utilization. So the next case I have is where you have large bandwidth utilization needs all throughout the day. This is a typical large mining company, and you can imagine terabyte-sized files coming from every mining device that's operating automatically. I don't have to give away the name, but you probably can figure out what this is. They're running automated machines, like almost, half a mile down into their pits. They're all automated, running by themselves. And each machine, as it runs, generates terabytes of data. And all that is being uploaded into their regional data center first, where they process immediate analytics and run the applications just to make sure that their operations are running fine. And then they offload that onto their larger data centers to do time series analysis on their data across multiple sites. So that's the other typical case where they're running multiple terabyte-sized files all throughout the day. So this is where the WAN capacity amplification comes into play. These are the typical two use cases that I wanted to cover, which would probably address most of your cases. So availability, scale, and as you scale, the capacity goes up too. How do you deploy these? So I have a couple of examples around. So two ways. One, you offsource it completely to VeloCloud. VMware runs it on your behalf, enterprise customers, or on your behalf, cloud providers. So we run it for you. We ship the edge appliance or the virtual network firewall to your customers, to your branch sites, and then we configure it and we run it, right? And then that's the entirely operate. So what's running where? So the gateways are running in our cloud. The orchestrator is also running in our cloud in our completely in the model where we operate by ourselves. Now there are variations from if you can get there to a cloud provider operated. A cloud provider can run all of this by themselves. They could run the gateways in their cloud. They could run the orchestrator in their cloud as well. And that's why they're managing all of their enterprise customers through their own SD-WAN deployment. And the flavors in between too, like the orchestrator can be running in the VMware cloud and providers running some of their own cloud. Some of the providers running the gateways. So there's lots of flexibility. And so this is a typical three-stage deployment in which they start with VeloCloud operating all of it. They take over the gateways and edge support, and then they take over the orchestrator. That's the typical three-stage process in which they go. So that's the flexibility. So summarizing, these are the three key takeaways. And for enterprise customers, you don't have to do this. Cloud providers can do it for you. Cloud providers, you can give them these benefits. And while you're doing application performance and simplifying the WAN complexity, you're doing this for them as well. You can offer these new services that you couldn't before. And the pull-through effect of all of this is that your cloud migration gets faster. It's an incentive for enterprises to be able to move their cloud services faster. So let me just quickly go through, we have 5 more minutes left. These are the typical our NSX websites where you can go to get more information. There are a few other sessions tomorrow and the day after that get into even more detail as to exactly show you how the orchestrator works and what the VCMP protocol is, if you're interested in that level of detail. And then we got the demo running in the VMware booth. Please go see the orchestrator demo running. All of this is available now, so you can see the demo and start a conversation either with your cloud provider or talk to us about exploring a proof of concept to start with one branch potentially. And with that, Let me stop there. We have about 5 minutes. Any questions I can answer? Yeah, please.
You mentioned that there are addable third parties from the ecosystem onto those edge devices.
Yeah.
Do the edge devices themselves come with any kind of basic firewalling or basic filtering or any of that kind of service?
Yes, yeah. The NSX SD-WAN has a basic firewall already attached. You could use that. Or if you need more advanced stuff, you can deploy the third party. Yeah, so I think either it's performance limited. We're working on improving the performance of our own firewall. That's why we partner with, it's easier to bring a third party best of breed instead of reinventing the wheel. So that's one reason why we do it. Yes?
All of my customers want multi-cloud, almost everyone.
Okay.
And efficiency also is Equinix as a launching point to the any of the clouds. That's one of our, we link into your gateways right into there, and you're right into the clouds.
Yes, so you could deploy the gateway. You can deploy the gateway in the Equinix, your colo. Your customers connect to that gateway, L2, and you could have a fiber connection between them and your.
All the exchange, it's already there, plug into it.
Yes. Yeah.
Simplification is very helpful.
Yes. Oh, good.
Assuming your limitation is 10 gigabits, right? Because if you need faster throughput, you need to go outside the box.
Yeah. So the 10 gig or the 1 gig is the branch side, right? The gateways are running at higher capacity because they're doing multiple tunnels, and especially when you deploy in a colo, that's easily you can fill up a 10 gig pipe, no problem, right? So and it's a software process, so it's your cloud cost that's going to increase as you deploy more and more of the gateway. Yes.
Question regarding the NSX as a service you're providing, right? As a service, are you referring to the NSX VE or T?
I'm sorry, NSX VE or DE?
Which NSX are you referring to? Which one you have already created demo based on?
Yeah, let me answer that question quickly. So it's the NSX SD-WAN by VeloCloud. This is the one that we deploy as a service. That's the one that I'm focusing on. So this, yeah.
Okay, so it's basically actually a repackaged based on what? Based on NSX, or it's a complete new?
So we bought VeloCloud early in January, right? So this is their product. Now, what we're integrating with NSX is most use cases, this is a branch getting to your edge router in your data center. And NSX starts from the edge router into wherever your application is running in the server. We're connecting the two. You need NSX manager to run your data center side. You need the VeloCloud orchestrator to run this side. Now, you could do lots of different segmentation. This is where they combine together, like your customer finance department versus marketing. You could start in the branch, have them segmented all the way into the gateway. The gateway maps to, you could put them into an IPsec tunnel to your edge router on your data center, and then from there you branch them off into the VRFs. So the segmentation is possible, and you could do this through running the NSX manager in the data center side and the VCO on the edge side. Yeah. Yeah. Any other questions I can answer? Great, we got 1 more minute left. Please fill out the survey, last request. Hopefully this was of value, so please fill out the survey, and then they'll probably allow me to speak again if that works out. Great, thank you very much for coming, appreciate it.